All right, I think I'm recording now. Let's see. Day 2, we start doing some math, and we need to do a little bit of vocabulary first. So the first thing that we need to, I don't like that shadow. That shadow's not going to go away. Okay, atomic mass. Atomic mass is on the periodic table. Okay, this is the mass of a single atom using units of AMU, which is what we, if you remember, um, we talked about this when we were calculating average atomic mass. Atomic mass units. Okay, so an example, one carbon atom is equal to, if you look on the periodic table, 12.01 AMU. Okay, the other thing that we can use the numbers on the periodic table for is molar mass. Okay, molar mass is the mass, exactly what it says, the mass of 1 mole, all right, of a substance. All right, what that means is that 1 mole of the substance is equal to the atomic mass in grams. So basically, we're looking at the exact same number. If we look at our periodic table, you are looking at periodic table. Kind of chemistry teacher am I? I don't have a periodic table handy. All right. So we're looking at this number, okay, on the periodic table. So silicon either has an atomic mass of 28.09 AMU or a molar mass of 28.09 grams. Okay. It's just a matter of what units we are talking about. Okay. So if we use this example, 1 mole of carbon atoms has a mass, which we can measure in the lab, of 12.01 grams. Okay. Basically, what that means is that if we have a mole of substance that's 6.02 times 10 to the 23rd pieces, it would have a mass of 12.01 grams. All right. So, some examples. So, this first one is, what is the molar mass of aluminum sulfide? Okay. So, we have to count our atoms. Okay. And we should be good at that by now. This formula tells me I have 2 aluminums and 3 sulfurs. Okay, so I'm going to look at my periodic table and I'm going to look. Aluminum has a mass of 26.98. I do want you to use this periodic table because that way our numbers will be consistent. Okay, so we're going to take that 26.98 and we're going to multiply it by 2 because we have 2 of those. So the mass of our aluminum is 53.96 grams. Then we have 3 sulfur atoms. Okay, so 3 sulfurs, 32.07. So 32.07 times 30, or excuse me, times 3 is going to give us 96.21. Is that right? I should probably check my calculator. So 3 times 32.07, 96.21. Check it out. I can do math. And then I'm going to add those two numbers together. So plus 53.96 grams gives me a total mass of 150.17 grams. All right. Now, what that means, and that gives us a conversion. Okay, we're using this molar mass to come up with conversion. What that means is 1 mole of aluminum sulfide is equal to or has a mass equal to 150.17 grams. All right. So we just established ourselves another conversion factor. All right. Let's see. What do we got next? So we've got another example. What is the molar mass of barium phosphate? Okay. So again, we've got to count our atoms. Okay. So barium, we have 3 barium. And then these parentheses, what these parentheses mean is that this 2 multiplies by everything inside of the parentheses. So that means I have 2 phosphorus and 8 oxygen. Okay, so if I look at my periodic table, I find barium has a mass of 137.33. Phosphorus has a mass of 30.97. And oxygen has a mass of 16.00. Believe it or not, you'll start to remember some of these. We use them so much. Okay, so now I'm going to do 3 times barium, 137.33, 411.99, 2 phosphorus, so 2 times 30.97, 61.94, and 8 times 16, 128. Now, if we add those 3 together, that's 61.94 plus 411.99, I get a molar mass of 601.84 equal to 1 mole, right, of barium phosphate. All right. So let's do another example. All right. So I'm gonna do a couple of these, and then I will let you do the rest for homework. Actually, I won't let you do the rest for homework. Actually, what I'll do, we'll do an example of each, and then I will have you bring this to class tomorrow, and I'll have you work on it in class, and just to kind of make sure that we are all on the same page. All right. So I'm going to pick a tricky one. I'm going to pick NH42SO4, ammonium sulfate. Okay. So now, and I say tricky because it's got parentheses and there's lots of stuff going on. So this 2 tells me I have 2 nitrogen, tells me I have 8 hydrogen. All right. Here I've got 4 oxygen and only 1 sulfur. Okay. So now I need to look at the molar masses on my periodic table. So nitrogen is 14.01. Oxygen is 16. Sulfur is 32.07. And hydrogen is 1.01. So if you haven't already figured it out, this semester is way mathier, if mathier is a word. So let's see, 2 times 1401 is 28.02. 8 times 101 is 8.08. 4 times 16 is that 64. Yes, it is. And then 1 times 32.07. So I'm going to add all of those together. Oops, dang it. 32.07 plus 64 plus 8.08 plus 28.02. And something you're going to hear me say a lot of this semester is show your work, show your work, show your work, show your work. Because if you don't show your work, I don't know whether you copied down someone else's answers or you actually did it. So 132.17 grams is equal to 1 mole of ammonium sulfate. Okay, let's hop over here and do a conversion because we just got to say 1 mole is equal to the molar mass, right? So, and of course, some of these that you've done, if you've done the math over here, we use some of the same compounds. So once you've done that side, you'll be ahead of the game. But I'm just going to do number 11. How many moles are equal to 89.23 grams of calcium oxide? All right, so we're going to do the same thing. What do we know? We know that we have 89.23 grams of CaO. And what are we looking for? We are looking for the number of moles of CaO. All right. So I'm going to set up my conversion. I'm going to start with my given, what I know, 89.23 grams of CaO. I'm going to put that over 1 because that's what we do. Now, what is my conversion factor? Okay. What we got to know, we got to know that 1 mole is equal to the molar mass in grams. Okay. In this compound, we're looking at calcium oxide. So calcium is over here, it's 40.08. Oxygen is 16. So that gives me a total mass of 56.08. So 56.08 grams of calcium oxide is equal to 1 mole of calcium oxide. All right, so now we're going to use that as our conversion factor. So 46.08 grams of calcium oxide is equal to 1 mole of calcium oxide. Okay, so I'm going to plug this in. 89.23 divided by 46.08 gives me 1.93614. How many digits do I need? Check it out. My given number has 4 sig figs, so we're always going to look at that. We're not going to count sig figs on our calculator. We're going to look at the number given in the problem. Okay, so we can have 4 significant numbers. So 1, 2, 3, 4. We look at the next one for rounding purposes. It's below 5, so we don't round. So our answer is 1.936. And our units, we cancel out grams, so that is moles of calcium oxide. All right. So I will see you in class, and when you get here, we will finish filling in this worksheet. Hope you have a great day. See you soon.